I've spent my entire life taking things apart. Sometimes to see how they work, other times because they're broken and I want to fix them. And you know what I've learned? Every single object, every single process is a story waiting to be told. Problem solving isn't some magical gift that only geniuses have. It's a skill. It's a mindset. It's about looking at a problem not as a wall, but as a locked door. And the best part is, you already have the keys. You just need to know which one to use. This is where the real fun begins, the detective work of discovery. Think about the last time something went wrong. Maybe your toast burned, your Wi-Fi dropped, or a project at work just wasn't coming together. What was your first reaction? Frustration? Maybe you gave up. I get it. But what if you saw that burned toast not as a failure, but as a clue, a piece of evidence, the start of an investigation? Problem solving is simply the process of gathering those clues, organizing them, and following them until you find the culprit. It's about asking the right questions over and over again until the answer reveals itself. It's a hunt, and you are the hunter. The world is full of complex systems. Your car, your computer, even the way you make your morning coffee. But here's the secret. Complexity is just a bunch of simple things stacked together. Our job as problem solvers is to peel back those layers. We need a system, a framework, to keep our investigation organized. Without a plan, you're just guessing. You're randomly poking at the problem, hoping to get lucky. I don't like relying on luck. I like relying on process. A good process turns a giant, scary monster of a problem into a series of smaller, manageable puzzles that you can solve one by one. So that's our mission today. We're going to build a mental toolkit, a set of reliable tools that you can pull out anytime, anywhere for any problem. These tools will help you look at a situation from every possible angle, so you don't miss a single clue. This isn't about being the smartest person in the room. It's about being the most curious. It's about having the patience to look closer, the courage to ask why, and the joy of finding out. Let's get our hands dirty and start building this toolkit together. It's time to stop being frustrated by problems and start getting excited by them. All right, let's get to the heart of it. The framework we're going to use is called the 6M model. Don't let the name intimidate you. It's just a fancy way of saying we're going to look at a problem from 6 different directions. Think of it like a detective arriving at a crime scene. They don't just look at the victim. They check the windows, the doors, the floor, the weather outside. They talk to witnesses. They consider everything. The 6MS are our investigative categories. They make sure we don't get tunnel vision and miss something obvious hiding in plain sight. It's a checklist for curiosity. The 6Ms are man, machine, method, material, measurement, and Mother Nature. That's it. 6 simple words. Each one represents a whole category of potential causes for your problem. When something goes wrong, the root cause is almost always hiding in one of these 6 areas. By systematically going through each M, you force yourself to think about possibilities you might have otherwise ignored. It's a structured brainstorming session with yourself. It turns chaos into order, which is the first step to finding a solution. It's all about making the invisible visible. Why is this so powerful? Because our brains love to take shortcuts. We see a problem, and we immediately jump to the most obvious conclusion. My coffee tastes bad, must be the coffee beans. But what if it's not? What if the water was too hot? What if the machine is dirty? What if I used the wrong filter? The 6M framework slows us down and forces us to be thorough. It prevents us from falling in love with our first idea, which is one of the biggest mistakes any builder or problem solver can make. It keeps us honest and open to all possibilities. So as we go through this, I want you to think of these 6MS as 6 different pairs of glasses. Each pair lets you see the world in a new way. First, you'll put on your man glasses and look at the human factors. Then you'll switch to your machine glasses and inspect the equipment. You'll do this for all 6 categories. By the time you're done, you won't just be looking at the problem anymore. You'll be seeing through it, understanding its inner workings, and pinpointing the exact spot where things went sideways. Let's start with the first M. The first M is man. This category covers everything related to the people involved in the process. And let's be honest, people are complicated. This M isn't about blaming someone. Blame is useless. It doesn't fix anything. This is about understanding the human factors that could contribute to a problem. We're talking about things like training, skill level, experience, fatigue, communication, and even simple human error. Did the person doing the job have the right instructions? Were they tired? Were they distracted? Were they properly trained for the task at hand? These are the questions we ask here. Understanding the human element is critical because most systems have a person in them somewhere. Even in a fully automated factory, a person designed the machines, a person programmed the software, and a person maintains the equipment. People are the ghost in the machine. For example, think about assembling a piece of furniture from a box. If the final product is wobbly, the man category asks, did I read the instructions correctly? Did I tighten the screws enough? Was I rushing because I was tired after a long day? It's an honest self-assessment, not a blame game. Let's use a simple example. Imagine you're baking a cake, and it comes out of the oven flat and dense instead of light and fluffy. Your first stop is the man category. You ask yourself, did I follow the recipe? Oh wait, the recipe said 1 teaspoon of baking powder, but I was talking on the phone and might have gotten distracted. Did I use a tablespoon instead? Or maybe I forgot it entirely. See? It's not about saying I'm a bad baker. It's about identifying a specific potential point of failure in your own actions. Maybe you weren't focused. That's a crucial piece of data. So when a problem pops up, always start by considering the people. This includes you. It's the easiest place to start your investigation. Look at the skills required versus the skills available. Check the training. Consider the physical and mental state of the person involved. Was there a communication breakdown? Did someone misunderstand an instruction? More often than not, the trail of clues begins with the human touch. Acknowledging this isn't a sign of weakness. It's a sign of a smart, thorough investigator who knows that we are all, after all, only human. Next up is machine. This M is all about the equipment, tools, and technology used in the process. Every job requires tools, whether it's a simple hammer, a complex computer, or a giant factory robot. When a problem occurs, it's essential to question your equipment. Is it the right tool for the job? Is it working correctly? Has it been properly maintained? A perfectly skilled person with a flawless method can still fail if their machine lets them down. This is the hardware part of our investigation, the nuts and bolts of the situation. Think about all the machines you rely on every day. Your car, your microwave, your laptop, your power drill. They all have one thing in common: they can break. Or they can just perform poorly. The machine category prompts you to inspect these tools with a critical eye. Is the oven not heating to the correct temperature? Is the saw blade dull? Is the software on your computer outdated and causing glitches? These are not passive objects. They are active participants in the process, and they can be the source of your headache. Don't just assume your tools are fine. Verify it. Let's go back to our sad flat cake example. We've considered the man factor. Now let's look at the machine, in this case, the oven. You ask, is my oven calibrated correctly? I set it to 350 degrees, but is it actually heating to 350 degrees? Maybe it's running hot and cooking the outside too fast before the inside can rise. Or maybe it's running cool and not providing enough energy for the chemical reactions of baking to happen properly. You could test this by getting an oven thermometer. See? We're moving from guessing to gathering data. That's the key. The machine could also be about maintenance. When was the last time the oven was cleaned? Is there old burnt food on the heating element that's affecting its performance? Or for another example, if you're trying to drill a hole and it's not working, is the drill bit dull? Is the drill's battery low? Questioning the machine is about being a good scientist. You isolate the variable, the tool, and examine it for defects. Never trust a machine completely. Always be a little skeptical. That healthy skepticism will make you a world-class problem solver. Our third M is method. This refers to the process you follow, the instructions, the recipe, the workflow. It's the how of the operation. You can have a great person and a perfect machine, but if the instructions they're following are wrong, the result will be wrong too. The method category forces you to examine the steps of the process itself. Are the instructions clear? Are they correct? Is there a step missing? Or is there a better, more efficient way to do it? This is where we put the standard operating procedure under the microscope. Every task has a method, whether it's written down or not. The way you tie your shoes is a method. The route you take to work is a method. The steps you follow to brew coffee is a method. When a problem arises, it's often because of a flaw in that sequence of actions. Maybe the order of operations is wrong. Maybe the timing for a specific step is off. It's about looking at the blueprint for the task and checking for errors in the design. It's not about how the steps are being performed, that's man, but what those steps are supposed to be. Let's revisit our cake disaster. We've checked ourselves, man, and the oven machine. Now let's scrutinize the method, the recipe itself. Where did this recipe come from? Is it from a reliable cookbook or a random website with no reviews? Did the recipe call for sifting the flour and I skipped that step thinking it wasn't important? That step is part of the method. Sifting aerates the flour, which helps the cake rise. Skipping it could be the root cause. Or maybe the recipe itself has a typo. Perhaps it says 1 tablespoon of salt when it meant 1 teaspoon. A flawed method will lead to a flawed result every time. This is why documenting processes is so important in workshops and businesses. When you have a written method, you can review it, test it, and improve it. When you're solving a problem, go back to the method. Read the instructions again, slowly and carefully. Ask yourself why each step is there. What is its purpose? Is there a better way? Sometimes we find that the official method is outdated or inefficient, and we can innovate a better one. Challenging the method isn't just for fixing problems, it's for making things better than they ever were before. Let's move on to our fourth M material. This category is all about the raw materials, the components, the ingredients, basically the stuff you're working with. You know, you can have a skilled person using a perfect machine and following a flawless method. But if the materials are bad, the final product will also be bad. It's that classic computer science principle: garbage in, garbage out. The material M really forces us to inspect the very building blocks of our project. Are they the right materials? Are they good quality? Are they expired or damaged? Everything is made of something. The wood for your bookshelf, the ink in your pen, the data you enter into a spreadsheet, the ingredients for your food. Yeah, all of that. The quality and specification of these materials are critically important. A tiny, invisible defect in a raw material can cause a massive failure down the line. That's why in manufacturing, quality control is so vital. They actually spend a huge amount of time and energy just inspecting the raw materials before they even start building anything. We need to adopt that same mindset in our daily problem solving. Back to our tragic cake. We've looked at the baker, the oven, and the recipe. Now we must investigate the materials, the ingredients. Let's start with the basics. Was the flour old? Old flour doesn't behave the same as fresh flour. How about the baking powder? It's a chemical leavening agent. If it's old, it loses its power and won't create the gas bubbles needed to make the cake rise. You can even test it. Drop a little in some hot water. If it fizzes aggressively, it's good. If not, you found your culprit. It wasn't you. It wasn't the oven. It was the material. This line of questioning applies everywhere. Building a deck and the wood keeps splitting. Maybe the material is too dry or a lower grade than you needed. Your 3D print is failing. Maybe the material, the filament, has absorbed moisture from the air, causing it to print poorly. Always question your materials. Check expiration dates. Check for damage. Make sure you're using the exact type of material specified by the method. Don't assume the stuff you're starting with is perfect. Inspect it, test it, and verify it. The problem might be there before you even begin. Our fifth M is a critical one: measurement. This is about the data you are using to control your process and judge your results. Measurements are the language of science and engineering. They turn vague feelings like too hot or too tight into concrete numbers that you can actually act on. This category asks, are our measurements accurate? Are we measuring the right thing? Are we using the right tools to measure? An incorrect measurement can send you on a wild goose chase, trying to solve a problem that doesn't even exist. or ignoring one that does. Think about how many measurements you use without even realizing it. The clock tells you the time. The speedometer tells you your speed. Measuring cups tell you the volume. These numbers guide our actions. If your clock is 5 minutes fast, you might show up early for everything. If your bathroom scale is wrong, it affects your health tracking. The measurement M reminds us that the data we rely on must be trustworthy. If your data is bad, your decisions will be bad. It's as simple as that. You have to be able to trust your instruments. Let's apply this to our ongoing cake investigation. We've checked the baker, oven, recipe, and ingredients. Now let's look at measurement. How did I measure the ingredients? Did I use a proper measuring cup? Or did I grab a random coffee mug from the cupboard? A coffee mug is not a standardized unit of measurement. That could be the source of the problem right there. What about the flour? Did I pack it down into the cup, or did I scoop it lightly? Packed flour is much denser, so you end up with more flour than the recipe intended, which leads to a dense cake. The accuracy of the measurement is key. This is why calibration is so important. Calibration is the process of making sure your measurement tool is accurate. We talked about checking the oven temperature with a separate thermometer. That's calibrating your oven's thermostat. In a workshop, you might use a set of feeler gauges or a caliper to take precise measurements. Are those tools themselves accurate? The measurement category demands precision, so when you face a problem, look at the numbers. Question them. Where did they come from? How were they measured? Can you verify them? Don't let bad data lead you astray. The final M in our toolkit is Mother Nature. This category, also sometimes called environment, covers all the external conditions that are beyond your direct control but can still affect your process. We're talking about things like temperature, humidity, lighting, noise, and even the time of day. We often get so focused on our immediate task that we forget that it's happening within a larger environment, and that environment can have a huge impact. It's the context in which the problem occurs. Think about how the environment affects everyday things. Paint dries slower on a humid day. Cars are harder to start in extreme cold. It's harder to concentrate on a task in a loud, chaotic room. These aren't faults of the man, machine, method, or material, but of the conditions surrounding them. Mother Nature is the silent partner in every project, and we have to account for her influence. Ignoring the environment is like trying to navigate a ship without checking the weather forecast. You might be fine, or you might sail right into a storm. So let's make one last visit to our poor flat cake. Could Mother Nature be the culprit? Let's consider the environment of the kitchen. Was it a very hot and humid day? High humidity can actually affect how flour absorbs liquid. A professional baker will sometimes adjust their recipe slightly on a humid day, using a little less water. Or maybe the kitchen was really cold, which could have affected how the butter and sugar creamed together, a crucial step for creating air pockets in the batter. Even vibrations from construction next door could, in theory, cause a delicate cake to fall. This is the final piece of our puzzle. When you've checked everything else, take a step back and look at the bigger picture. What's going on around the problem? Is the lighting in the workshop too dim, causing you to misread a measurement? Is it so noisy that a critical instruction was misheard? Is the room too dusty, contaminating your project? The Mother Nature category is your reminder to always consider the context. It completes our 360-degree view of the problem, ensuring no stone is left unturned in our quest for the root cause. Now you have the tools. You understand the 6 Ms. Let's put them to work on a real-world, everyday problem. Let's call it the case of the sad, soggy sandwich. You pack a sandwich for lunch every day, but by the time you eat it, the bread is wet and falling apart. It's a tragedy. So instead of just suffering, let's be detectives. We'll use our 6M framework to find the root cause. We'll create a simple fishbone diagram, with the soggy sandwich as the problem at the head and the 6 M's as the bones. First, man, how am I making the sandwich? Am I assembling it in a rush? Maybe I'm not careful and I'm letting wet ingredients touch the bread directly. Am I packing it correctly? Perhaps I'm squishing it into my bag. Let's list these as potential causes. Second, machine. What tools am I using? Is my knife sharp? A dull knife can crush the tomato instead of slicing it, releasing more juice. What about my container? Is it airtight? Maybe it's trapping moisture inside, creating a little steam room for my sandwich. All plausible theories. Third, method. What is my process for building the sandwich? What's the order of ingredients? Am I putting the wettest ingredients like tomatoes and pickles right next to the bread? That's a classic recipe for sogginess. A better method might be to create a moisture barrier. For example, putting lettuce or cheese between the tomato and the bread, or toasting the bread first to make it more resistant to moisture. The sequence of assembly is a critical part of the method we need to investigate. Fourth, material. What are the ingredients? Is the bread too soft and absorbent? Maybe a denser bread like rye or sourdough would hold up better. Are the tomatoes extra ripe and juicy? Maybe I should pat them with a paper towel before adding them. Is the lettuce a wet variety like iceberg? Spinach might be a drier alternative. Fifth, measurement. This one is a bit trickier for a sandwich, but it could apply. Am I putting too much mayonnaise or mustard on it? An overly generous measurement of spread can definitely lead to a soggy mess. And finally, sixth, Mother Nature. Is my refrigerator too cold, causing condensation on my ingredients? Or am I walking to work on a hot day, causing the sandwich to sweat in my bag? By looking at the problem from all 6 angles, we've gone from my sandwich is soggy to a whole list of specific testable ideas. Now we can change one thing at a time, like using toasted bread, and see if it solves the problem. This is how you go from being a victim of circumstance to the master of your lunch. Go forth and solve.